CE 304 Assignment 1 Exercise 1. Right, we're asked to show that P and Q or R implies P and Q or P and R. First stage, go backwards. Using implies introduction, we have to prove that P and Q or P and R follows from assumption 0, which of course is this, P and Q or R. Right, well, we can try to prove this by the OR elimination from here. So we're going to prove it by Q or R, and we get Q or R from P and Q or R, which is assumption 0. So we have to prove P and Q or P and R twice. This gives us assumptions 1 and 2 in the various columns. In the first and the second column we get Q, and in the other column we get R. Well, not going to be too difficult. Now we can get this from P and Q, and we can get P and Q from P and Q separately, and we can get P from P and Q or R, assumption 0, and we can get Q from assumption 1. On this side, we're going to get this from P and R, which we get from P and R. The P we get as before from P and Q or R, assumption 0, and R we get assumption 2. And the proof is complete. Okay, so actually the main problem that people had with this one was this bit of the proof down here. The assumption is P and Q or R. We have to do an OR elimination, but what we've got is a conjunction. We just have to get the Q or R out of it, as we do in that column there. And once that's through, really, it's pretty well plain sailing. CE 304 Assignment Exercise 2. Okay, now we've got to prove that P and Q or P and R implies P and Q or R. Implication, go backwards. We have to prove P and Q or R, and we have to do that on the basis of the assumption 0, which is P and Q or P and R. Okay, this is a conjunction. We have two opportunities here. We could either do the elimination now, or we could do the and introduction now. Most of you did the and introduction now, which is perfectly fine, so let's do that. So we just split that up into P on one side and into Q or R on that side. Tackling the P, okay, so we can do that using our assumption. Let me just write that as a little box. So this assumption 0, I'm writing the little box so that I've got space for it. So there we have it. Then I've got to prove P twice. I get my assumptions 1 and 2, and assumption 1 will be P and Q, and assumption 2 will be P and R. How do I get P from P and Q? Like, that's not difficult. And how do I get P from P and R? That's not difficult. Now on this side again, I'm going to use the OR elimination, the same thing. So let me just write my little box there so I've got space to put it. And now I've got to prove Q or R twice. And I've got assumptions here now 3 and 4. Assumption 3 will be P and Q, and assumption 4 will be P and R. So how do I get Q or R rather, from P and Q? Well, I get that via Q. How do I get Q or R from P and R? Well, I get it through R. And the proof is complete. CE 304, assignment 1, exercise 3. Okay, we've been asked to prove P or Q implies, not P or Q implies that Q must be true. Outermost connective is the one on the left, so we have to prove that not P or Q implies Q on the basis of assumption 0, which is P or Q. Now we have to prove Q on the basis of 1, which is not P or Q. Fine. Now we can do our elimination. Well, we've actually got a choice, but let's do this one first. Not P or Q. Which is assumption 1, and we prove Q twice. Well, we have assumptions 2 and 3 here. Assumption 2 is not P, and assumption 3 is Q. So Q is immediate. And this side, the Q. How are we going to get this Q? Well, let's eliminate P or Q, which is assumption 0. And we can have Q twice. Now, once again, we have assumptions now 4 and 5. 4 is P, 5 is Q, Q goes immediately, and this Q here we can get as a contradiction between, well, actually we can get it by that contradiction between P and not P, which is 2 and 4. And the proof is complete.